Okay, so we have done VPC peering and we ran across a couple of problems. So VPC peering, first of all, doesn't scale. I mean, when you have multiple VPCs, it becomes very difficult to manage all those route tables. We also saw about how VPC peering doesn't allow non-transitive routing. And another part of it, so basically managing dozens or hundreds of peering connection becomes a nightmare. Um, becomes a nightmare. I was going directly to Transit Gateway, Night Gateway. Interesting. So anyway, the solution becomes the Transit Gateway, and with the Transit Gateway, it acts as a central hub that manages all our VPCs. So instead of having peering connections that go like this and then like this and then like that, yeah, and managing the route tables, all these places, we just have a central hub, which is the Transit Gateway, and just make attachments to our VPCs. So all these are attached over here and can communicate with each other. That is why we call it a central hub that all our VPCs connect to. And one cool thing, we can also connect to our on-prem networks using the VPN or direct connect and so on. So VPCs don't talk to each other directly, they talk through the Transit Gateway, and it's very scalable because we can connect up to thousands of VPCs and just connect them to a single Transit Gateway. And it can also work across accounts and regions when we bring in the RAM, not random access memory, resource access manager that enables sharing of resources across account. So when do we use Transit Gateway? We have multiple VPCs that need to communicate. We want centralized network control, in this case, a single place to manage all our routes. We do need transitive peering, where VPC A can now communicate to VPC C using the Transit Gateway. And we are thinking long term, want to add more VPCs in the future. When do we not use the Transit Gateway? We only need 1 or 2 paired VPCs. Transit Gateway will add more complexity and cost in that manner. And if we don't need transitive routing, yeah, let's use VPC peering. Use the right tool for the right job. So let's go and get started with setting up our Transit Gateway. So our architecture still remains like this. Let me clear the mess. Yeah. So now we'll be dealing with the Transit Gateway. So we'll be attaching a Transit Gateway to our VPC, basically creating one and setting up the attachments to this specific subnets. My CloudFormation template already created the Transit Gateway subnets for VPCs B and C. So we'll just go ahead and set it up for VPC A so that you have an overview of what takes place. Okay, back to the management console. We go to our Transit Gateway, create this. So I'll just call it Kira DGW. So Transit Gateway for US East 1. Oopsies. Okay, so one thing I'll enable right now is multicast support, not because you're going to use it now, but because in the next lab, I would love to set up this Transit Gateway multicast and see how it works. So I'm just enabling that for now, yeah. And then the Transit Gateway CIDR blocks, just leave it as optional, and create our transit gateway. So the state of our transit gateway is now pending. As I mentioned, best practice. For connecting our VPCs to our transit gateway, we need to use like a dedicated subnet of /28 in each availability zone. And as I mentioned, the CloudFormation template we ran earlier created this for VPC B and C. So now we are going to create our subnets for VPC A. So back over here, quickly create the subnets. Create subnet, VPC ID. So this is for VPC A. Give it a name. So this is VPC A Transit Gateway subnet in availability zone 1. Is 1. So will be in availability zone 1A. That is the VPC CIDR block, and the CIDR block of our subnet /28. I think that's okay. So I'm going to add a new subnet, and this is for AZ2. In availability zone 1B, and the CIDR block 10.0.5.16 /28. Figure out the calculations of the CIDR blocks later on. Okay. So, yep, this is AZ2. And create subnets. Okay. So now our architecture looks like this. We have the transit gateway subnet set up in all the VPCs, in all the different availability zones. So what do we go ahead and do? Now create a transit gateway attachment for VPC A, VPC B, and VPC C. So back to the console, we have created our subnets, transit gateway attachment. We are going to create one. So this is VPC A attachment. The transit gateway ID is the Kira line. It's attached to VPCs. So VPC ID, this is attached to VPC A, and the subnets, transit gateway subnets for the different availability zone. Create the transit gateway attachment. I want to create the same for VPC B. VPC B attachment, Kira line transit gateway. The VPC is VPC B, and the subnets, this is attached to the transit gateway subnets. Okay, the three attachments are now in pending state. And what do we notice? So when you create these attachments, what basically happens is interfaces are created in each of the different availability zone. So if we look at our architecture, back over here, what is happening is we are creating a network interface attachment in all these availability zones. And we can definitely see that from the EC2 section. So if we just go to instances and then view the network interfaces, so we can see a couple of network interfaces for the transit gateway attachment. So we can see interface type 1, 2, 3, 4, 1, 2, 3, 4, 5, 6 attachments, and you can see in all the different availability zones 1A, 1B, 1A, 1B, and they are all connected to the 3 VPCs and the private subnets. So that is what happens now that we have the attachment in all the 3 VPCs. So the next thing is to add the routes to the route table to point traffic to these interfaces. So back to the route tables and VPCA, private route table, edit routes, and add a route. So we can say, let's just start with how we used to do things, but I'll show you a better way to do this. So we are saying any traffic going to this VPC should go through the transit gateway. And let me just remove the peering connection. Okay, and another route. So any traffic going to VPCC also goes through the transit gateway attachment. Okay, go back to the route tables, edit the route table for VPCB. A good way to go about this, instead of adding the one-on-one routes, we can just add an aggregate route. So that aggregate route, basically we are saying anything going to this destination 10.0.0.0/8, which basically covers our VPCs, which are /16. So the target is the transit gateway. And then we go to VPCC. I'm going to remove the peering connection and add a final route. So I'll also add an aggregate route. Anything to that big network goes through the transit gateway and VPCC attachment. Okay, so what did you notice? Right now, we are not editing the routes in all the different VPCs, which makes it very easy. And we have our main route table. So for the transit gateway, which I'll show you in a moment. So all the routes have been created for VPC A, B, and C. And now we'll just go ahead and test connectivity over here. Okay, back to our EC2 instances. Okay, let's start with VPCC server, connect to it. And then VPCB Okay, let's start with this one. So this was instance ID with ED. So VPCC private server, here it is. So let's try paying the instance in VPC A and B. So we are able to reach our first EC2 instance, and then we try instance in VPCB, also reachable from VPCC. Here we are in VPCB, I believe. So let's try paying the instance in VPCA, reachable, and VPCC, all works. And here we are in instance A. So let's ping instance B. All good. And instance C. And all work with our transit gateway connection. So all of them can now communicate with each other, and our final network looks like this. So we have created our transit gateway, and we set up our network interfaces basically by setting up our route table to our attachments, our transit gateway attachments, and our route tables to route traffic to those specific VPC attachments. And now all the instances could basically communicate with each other in these VPCs. Now, if we just take a look at the route table of the transit gateway right now, so this is the route table of the transit gateway. Let's just take a look at it. So we can see the associations. All the three associations are there for the three VPCs are associated with each other. The propagations too for the different VPCs are all set up. That means all routes are propagated, meaning every VPC can see every other VPC unless we isolate them. And the routes, we also have the three routes to the three VPCs. So this is by default with the transit gateway route table. What we need, if we need some sort of isolation, it's not all the time that we want all these VPCs to communicate to each other. And a good example is if we have a shared services, VPCs. So for example, we have a shared service here that we need VPCB to have access to and VPCC to have access to, but VPCB should not be able to have a connection or communicate with VPCC. Is this possible using the transit gateway? And the answer is yes. We can modify, create our custom route tables, add static routes, and make sure that we create some form of isolation. So let me just show you how we can quickly do this. So of course, by default, the transit gateway will automatically associate any newly attached VPCs to the default route table and propagate routes from those VPCs into the transit gateway route table. So by default, all VPCs have connectivity to the other VPCs. Now, yep, so let's go ahead and show you how we can do this. So first things first, We are going to assume our VPC-A is the shared services VPC. And shared service VPC could host services, for example, the DNS, LDAP servers, or any other shared resources. So what you're going to do with the transit gateway route table is delete the VPC-A attachment from the transit gateway route table. So how do we delete that attachment? The first thing we need to do is delete the association of VPC-A from the default route table. Now I really have to get the VPC ID. So I'll just open this in a new tab. So VPC-A 9C, okay, can work with that. So this is VPC-A, and I want to delete the association with the main route table right now. So it's in the status, disassociating right now. So the next thing we need to do after deleting the association, we will delete the propagations that were automatically created for both VPC-B and C. So that the only remaining is that of the VPC ID of VPC-A. And this will also remove the routes of VPC, B, and C from this specific main route table. So we'll go over here. I know this is the VPC ID of VPC-A. So I want to delete the propagation of the other two VPCs. And if we check the routes, it will the routes were automatically removed for VPC-B and C. Why? So now these VPCs cannot reach each other using this specific route table. Okay, so the attachment for VPC-B and C, okay, this should be C, are still associated with the original route table. So this means that both VPC-B and C are able to reach VPC-A via the route table because there is a route for 10.0.0/16 being propagated into it by VPC-A. However, the attachment, so here we're talking about propagations for these two, but the attachment for VPC-A is no longer associated with the route table, and therefore there is no routing information that will allow VPC-A to reach VPC-B and C, okay, from VPC-A. So to add these routes, we are going to create another route table that VPC-A is going to use. So let's go ahead and create the shared services route table in this case. So in the transit gateway route tables, I'll create a transit gateway route table. So this is the shared services. So attached to killer line transit gateway, I'm going to create that. Okay, it's now available. So let's go ahead and do our magic. So we want to associate this with VPC-A, VPC-A attachment. And then we want to create the propagations for VPC, B, and C in this case. So this so that the route table over here, look at the routes. The two routes have been created for VPC B and C. This route table now knows how to access the other two VPCs. So VPC A now has a return path to both VPC B and C. So our route table, which is associated with VPC A, has a route to VPC B and C. And then the route table, which is associated, the route table on the other end has a route to VPC A. They all know how to access VPC A. And this other route table for VPC, which has an attachment to VPC A, knows how to communicate with the other two VPC B and C, but the two do not know how to reach each other. So let's go ahead and test this out. Here I'm in VPC C, and let me start with VPC A. So ping VPC B, instance in VPC B, the count of 5. And how about C? Awesome. In VPCB, let's try ping instance A. About instance C. And nice. So it's basically timing out because B and C, with the isolation we have made, they should not be able to communicate with each other. Now from instance C, let's try get to A. And how about D? Also timing out. Yep. Okay. So now because we have deleted the association in the main route table, VPCB can talk to VPCA, but VPCB cannot talk to VPCC. And by that, we wrap up our demo. We have established network segmentation using the transit gateway route tables. And yep, thank you for staying. See you in the next one. Bye-bye.